This is Samad here from VBind Education Technologies Mumbai. VBind brings industry experts live into your classrooms. And to help you understand better what exactly VBind do, I'm going to play a very short video.
Rohan and Rita are engineering students. They are studious and smart. They work. Rohan and Rita are engineering students. They are studious and smart. They work hard and get good grades. It's a happy story. But here comes the villain. They're confused about their future. They find no connect with the subjects they study and what career they want to pursue. Professor Nandlal is a very senior lecturer. He has sensed this issue with many other students like Rohan and Rita. He is worried too. He sets out on a mission to find a solution. He does some research, tries to find out who can help him bring the real corporate world into the classroom. He wants someone to help students gain knowledge and experience of the practical world. And voila, what does he find? VBind, bringing industry to classroom. VBind has a list of industry experts as masters on their platform. By means of VBinders, these masters interact with students like you. These VBinders are called masterclass. What do we expect from a masterclass? Stories of inspiration and experience, tons of information on new products and the ideas behind it, useful insights on how to step into the industry, chance to interact and pitch ideas to the movers and shakers of the industry. One such masterclass is waiting for you. Come, let's hear the master. And yes, don't forget to like us on Facebook or tweet to us at VBind. We appreciate your feedback by just a WhatsApp on 088 791 63528. We promise to bring the Tatas and Bansals and the Murtis to you soon. Help us get them live on your screens.
So the topic for today is microcontrollers, and we have got Mr. Premchand as a master for today. And so a short introduction about Mr. Premchand. Uh, Prem sir has completed his engineering in electronics and communication from Jawaharlal Nehru Technological University in the year 87. Thereafter, he joined his MTech from Hyderabad Central University, and in the year 1988, he completed and started working with Bharat Electronics Limited in Bangalore. Thereafter, he started working for BEL, a Government of India Limited company, until the year 1992. In the year 1998, Mr. Premchand started Soroka Soft with a team of professionals. So Mr. Premchand is an entrepreneur by profession and by nature. In the year 2004, Mr. Premchand set up an embedded system company called as Econ Embedded Systems in association with a business accomplice. Thereafter, with his social networking skills and for a social cause, Prem sir started Essence, that is Empowerment Society for Skills Enhancement, in the year 2008. So with an experience ranging of around 30 years, here we have Mr. Premchand for colleges from Jammu and Kashmir, SSM College from Jammu and Kashmir, and Usha Mittal College from Mumbai. So without any further delay, I invite Mr. Premchand to take over.
Is it audible?
Yes, it is audible, sir.
Okay, today's session is on microcontrollers. Before I would get into the core of the subject, I would like to first go through the word microcontroller itself. So it is two words, micro and controller. Am I right? So the words micro and controller. So controller as such is an English word, like you have a driver, you have a conductor, you have a tailor, you have a collector, you have a commissioner, so you have a controller. I think most of your universities also would have a designation called as a controller of examinations, if I'm right. So broadly, I think let's demystify the subject. Let's not feel too complicated. That is a too complicated subject, not at all. It's microcontroller is a micro is small, controller is a entity or a device which controls. So controller can also be used for humans who are controlling things. So with that demystification of what a microcontroller is, let's move forward into the presentation. I would not cover the theoretical aspects because I think most of your class would have already gone through what a microcontroller is from the theoretical perspective. What is already been explained in the textbooks and your class. So I would focus more on the application aspects for all sorts of domains. It can be just a simple home automation domain, or it can be for a defense application or a missile application or a space application. So with a small intro, I will switch on the PPT. Maybe through that, as we go through that, I think we will pause that and then get into the more specific aspects of applications. So as we already discussed, the topic is on microcontrollers and its applications. So there we go. As already indicated in the introduction, microcontroller is a small computer on a single integrated circuit, which contains a microprocessor as a core, and along with the memory and programmable peripheral interfaces. So as all of us know that microcontroller market is a huge market. You have microcontrollers in almost most of the devices, like washing machines, air conditioners, micro oven. You can also consider microcontrollers and some extended functionality chips on devices like mobile phones, monitors, television screens, LCD projectors, healthcare equipment like pacemakers, whatnot. I think microcontrollers are today embedded into every part of what we do on a per-day basis. So what we can do, of course, we can, as you're seeing on the screen, we can control things, we can sense things, like we can sense humidity, or we can sense a motion, or we can sense the door contacts, or we can do infrared ranging, or you can display things. You can have asset tracking using RFIDs. We can do shower control or light control or fan control. So whatnot. I think the applications can be anything. It can be used for display applications, for entertainment sort of stuff, or it can be used for complex applications. So I just pulled out a slide from over the internet on the total evolution of the microprocessor, and of course microcontrollers also are stemmed out of the same classification. So we have, it all started in 1971 with 4004. Then we had, it's a 4-bit microcontroller. Then we have 8008, again from Intel Corporation, 8080, 8085, 8086, and whatnot. I think we have 16-bit processors, 32-bit processors, today 64-bit processors coming up. And as we have one main branch of all this process, right from 4004 to the current RISC processors that are coming up, we also have two branches. One we can consider as a special purpose processors for areas like digital signal processing and things like that. So primarily we use a lot of chips from Texas Instruments or NLAC devices on the DSP front. And we have other branch out which we call as embedded systems branch, which has microcontrollers, right? Like 8045, 8051, 8096. When you talk about 8051 as a microcontroller, it's a family. So 8051 is not just 8051 itself. 8051 is a family of microcontrollers from different manufacturers like Intel and Atmel, Microchip, and things like that. And we have controllers which are just digital in nature, which take digital input and process it and give digital output. And we have microcontrollers which are also mixed signal. When I say mixed signal, they have both analog and digital both on a single chip. So we have ADCs, that's analog to digital converters, DACs, which are digital to analog converters, all embedded on a single chip. These are the advanced microcontrollers today we use mostly in the industry. There, for example, we can talk about something like Silicon Laboratories chips called C8051, F020, or 120 or 124, and family of chips. We have a lot of chips from Philips. We have chips from NXP. We have Texas Instruments chips, which have multiple functionalities, not just digital but also analog, and we can connect a sensor to a signal conditioner to this and get the output. Again, I pulled out another slide from somewhere on the internet.
So sorry to interrupt. This is Samad here again.
Yes,
so there is a request from SSM College that the voice is a bit unclear. So if you can place your mic strategically, it will be very helpful.
Okay, right. Is it clear now?
Just give me a thumbs up. Just give me a thumbs up as a SSM College. Just raise your hand.
Okay. Is that okay?
Yes, there is a hands up. There is a hands up from the college.
Okay. I'll continue.
Yes, sir. Please.
So, because I think the last slide was not very clear, I'll just go back to the previous slide once. I was referring to the evolution tree of the microprocessors. As we all of us know, we all started in 1971 with 4004 from Intel Corporation. Then we had 8008, an 8-bit microcontroller, and we have 8080, 8085. At the stage 8085 came up in 1976. We had two architectures that are coming out. One is 8085, and another company called Zilog Corporation for Z80 process started to got manufactured, and both of them are competing in the specifications and features. So we have one Zilog Z80 and Intel's 8085. Feature rich, Z80 is very, very feature rich. Intel, of course, had a better commercial wisdom or business sense. So Intel prevailed with much more successes on the microprocessor and microcontroller field, whereas Zilog still, I think, still holds some of the process and good architecture. But I think commercially, Intel is what we hear more, has been more successful. As explained, I think the audio was not very clear. I'm just repeating it. We had two branches. One, we have special purpose controllers coming up, especially in the areas of DSP and things like that, which are used primarily in the communication and other areas, signal processing areas. And even another element of other branch coming out in the microcontroller segment, which we generally call them as embedded systems, which have processing of analog, digital, storage, some amount of signal processing wherever it's required. So in that family, I think 8051 is very popular. We have an Intel 8051 family of processors. 8051 is not a single chip as such. It's a family of chips. Like we have 89. We have we have Atmel 89C51 or 89C52 and things like that. And we have advanced controllers like Silicon Libraries C8051F020 or C8051F124 and things like that, which also have interface like USB and analog and digital circuitry, including analog to digital converters, digital to analog converters. Just moving to the next slide. Pull out from the internet again. It's in applications. Could be for the general purpose microprocessors. The applications could be like making desktop computers, personal computers, laptops, workstations, servers, and microcontrollers, microcomputers. Supercomputers. We have PC, which was a 16-bit microprocessor, like 8088 was used in PC, original PC. Then we had PC XTs, PC 80s, PC 386 computers, 486 Pentiums, and so on. So now we have 64-bit general purpose computers. These are all microprocessor applications. Primarily, they are general purpose in nature. Of course, we can also build special purpose or embedded systems with microprocessors with add-on memories and peripheral devices. In the microcontrollers, of course, we have embedded systems. It can be consumer electronics, which could include toys, cameras, camcorders, robots, washing machines, microwave ovens, and in the instrumentation segment, like maybe most of you would have seen it in your laboratories, oscilloscopes, and maybe in the hospitals we see medical equipment. These are all microcontroller-based applications. Continuing further, we have in the process automation. Maybe you go to an industry like cement industry or automotive industry. We see a lot of data acquisition systems. Maybe when you say something in the power and energy segment for making turbines. In fact, most of our products when we do build for companies like BHL, we have a lot of data acquisition systems built around microcontrollers. In the communication equipment, like the telephone sets, answering machines, cordless phones, fax machines, printers, these are all microcontroller-based applications. So now that we broadly thought about covered what a microcontroller is and what could be the applications of microcontrollers, let's be very clear. It is not pure software. It's not pure hardware. If you want to be an embedded system developer, you need to have three facets. One is you should be good at hardware. So you are a hardware designer. You're also a software designer, and you should have the abilities to integrate both. You're three-in-one sort of a stuff. Like we have possible. The system integration means you have to integrate the hardware and the software together to build a whole system. It's not complicated as what you may think that it's complicated. It's not at all complicated. It is very simple common sense required to build embedded systems using microcontrollers. Let's talk about one sample application because time is limited. We have about a few minutes to go now. So we will take up one example, like maybe interfacing a keypad or a display sort of a requirement. So let's say we have a microcontroller and we have to interface a keypad and a display to the microcontroller. Before I get there, I think all of us should understand that any system would need to have an interface to it. Like as a human would like to communicate with the device. Like you have a mobile phone, the touch screen is where you're providing your inputs to the phone. The display is where you're getting the output from the phone. And also the output is also coming out of the phone through the loudspeaker. The input is also going to the phone through the microphone. So every device, any equipment or any system for that matter will have some inputs and some outputs. So in this application, in this example, what I'm talking about, we have microcontroller. Let's say one input device called keypad has to be interfaced to it, and we have to interface an output device, for example, a display unit. Just again, a small snapshot in whatever limited time we have. We just put a snapshot here of possibly interfacing a IC 8051 to a keypad. In this case, the keypad we have configured as a row call matrix. We have a few rows and few columns, and we have rows into columns number of keys that can be interfaced to the microcontroller. In your application, if you have only one key to be interfaced or two keys to be interfaced, key is nothing but a push button. Key is nothing but a switch. So if you have only few keys, then you need not go through a switch matrix of row and column. You can just interface 3 keys or 4 keys, whatever you need, to the port lines. I'm referring to the word port, P-O-R-T, port. Port has exactly the same meaning as a port, what we use in case of an airport or in case of a regular port, maybe say Mumbai port or Kolkata port or a Visakhapatnam port or a Machilipatnam port. These are all ports. Airport is a port. Similarly, it is almost the same meaning of that of any port. Even in a microcontroller or a microprocessor-based system, the port indicates that is a place at the point through which there is a transportation or the movement of in or out happens into the system. So an airport is a place where there's the people come in into the territory or go out of that. So broadly, after you understood the word port is an input or output transaction place. So in this case of microcontrollers also, let's use ports for that. So a port can be an input port or an output port. Input port is a place where the data goes into the controller. The output is the port is a place where the data goes out of the. It is very similar to when you go to the bank counter, you have receipts and payments. The receipts counter is where the bank receives, and the payments counter is where bank pays. So that means that the word of read or write or input or output are with a reference to the subject. The subject here is the microcontroller. So if the microcontroller is to read something, then it needs to read it through an input port. If the microcontroller has to write something or output something, it has to write it onto an output port. I hope I'm clear about those definitions. So in this particular example, we are interfacing a 2 7-segment displays. 2 7-segment displays are interfaced to the microcontroller C8051. So in this case, we have used a chip called IC7447, which is a BCD to 7-segment converter. So we may use it or you may not use it. If you don't want to use a chip like that and you would like to directly control the LEDs of a 7-segment directly to the port pin through a buffer, it can as well be done. By using an IC like 7447, we are reducing the number of port lines which you would be requiring to control a 7-segment display. As all of you know, that 7-segment display has totally 8 LEDs, A, B, C, D, E, F, and G. To light up those 8 LEDs, you need 8 port pins. To reduce the number of port pins, in this particular example, we have used an IC called 7447, which converts a BCD number into the 7-segment. So that's one simple application. We don't want to complicate it with complex applications, but one simple application of interfacing a keyboard matrix and a display. The rest all would now go into the software perspective. So in the software, you would have to write program which will scan the keypad and get the key that is pressed, and based on the application logic, based on what you would like to display, you can send the data on the port lines. In this case, is P2.0 to P2.3. That's the 4 port lines. And P2.4 to 2.7, that's under 4 port lines, we can send out the BCD number to get the 7-segment number displayed on the display. So listed here are some of the application domains in which we can use microcontrollers effectively. Let's talk about what is happening in the world today, or what's happening especially in our country. We can build applications for what's currently happening. Like maybe we can build microcontroller-based applications, products with hardware and appropriate software for maybe the government's mission of Swachh Bharat. We can build a small device which can go on to your garbage collection system, or a municipality system which will an automatic alert is sent to the municipality based on how much garbage is filled. So we can build any system as long as you have specified input and you have some processing to be made, and you can send out a message via GSM modem or an equivalent device or over the internet. So we can always build systems for Swachh Bharat. We can build a system, or we can build a lot of applications for smart cities or safe cities. There's a technology, there's a word called as IoT. I don't know how many students here are aware of the word IoT. Can you raise your hands if you know IoT? What is IoT? Can you raise your hands if you know the word IoT? No? So nobody knows IoT? IoT stands for Internet of Things. There is another word called IoE. IoE stands for Internet of Everything. This is the word coined by Cisco. So in applications like Internet of Things, wherein you can collect the data and put it over the cloud or over the internet and take some decisions based on the data that you have. So there are a lot of products that are coming up which are cloud enabled today. Maybe you have a glucometer. Glucometer is a device used for measuring the blood glucose levels. You can have a glucometer connected on the cloud using a microcontroller based add-on circuit, which allows the doctor to monitor the blood glucose levels of a patient and based on that prescribe the medicine. So on and so. There's one application. So there's a case of a healthcare. We can build applications on microcontrollers on healthcare. The power and energy segment, as I already mentioned, if we can build a turbine data acquisition system, or energy maintenance system, or energy conservation, or maybe you can build systems which based on the proximity of people or the detection of the people, it can switch on or switch off lights, thereby conserve energy. Of course, a lot of microcontroller based applications we build as part of our company, Serapa Software upon embedded systems into the field of aerospace, defense, and other mission critical applications. In the education segment, a lot of education tools that can come up with process and controllers. Entertainment, all of us know that most of the entertainment devices and toys are built on microcontrollers. Communications, when I say communication, it could be communication of the data or the communication of. Is it audible? Is it audible?
Yes, it's clearly audible, sir.
Okay. So in the communication, I think all of us know that we can build data communication or communication which sends out information like the oxygen levels or the nitrogen levels or the pollution levels, carbon monoxide levels in the atmosphere, and based on that we can take decisions. Like Pollution Control Board of the country has decided to set up various data collection centers throughout the country through which we can monitor the pollution, based on that take decisions. So there's a lot of applications which can be built on microcontrollers, provided we know what type of data we'd like to collect and what type of control we'd like to do on it. So in the automotive, transportation, today I think we see most of the cars manufactured today, and even the buses and trucks, and all of them have microcontroller based circuitry in them. The technology, what we see as variable valve technology, about the VVT of most of the cars we have, they are all controlled using a microcontroller based system, to which the fuel is injected at the right time with the right amount, so that it's fuel efficient. Again, I think one more application could be in the infrastructure. You can build there are a lot of systems that can be built for surveillance or asset tracking, that you would like to track a particular item using RFIDs or GPS, or maybe other technologies. Shall I stop?
Yes, sir.
I think somebody is interested in talk.
No.
Shall I continue?
Yes. Is there a question from Jammu Kashmir?
I think so. I think one of the students is trying to.
Hello?
There is a lot of disturbance from your college. So please ask the students to first maintain silence and then start with your question.
Sir, we are all silent, but our voice is not clear. That's the problem.
Sorry?
I think the audio is not together.
Voice isn't clear.
Okay, I'll continue with. I think maybe I think there's some problem with the audio there, but I'll. So asset tracking, I was mentioning about asset tracking.
Sir is talking about applications, and we don't want to listen to the application. We want the basic concept of microcontroller.
I think it's already covered in your syllabus, right? So is it that you already gone through the syllabus?
Yes, so this session is all about the applications of microcontroller.
You want the.
And if at all the theoretical part, so I think the professors at your college would be very well equipped to make you understand the practical, the theoretical knowledge of microcontrollers, if I'm not wrong. So you may please continue.
Yeah. So this session is primarily application specific. We can probably have a session if required on the basics also at a later date. So I think as mentioned in the format of our presentation, I think the career options and the scope that this particular technology would offer to you is a lot of scope in the research and development, and probably you can build products and devices based on this. And as we are practitioners, we use these things in defense and micro and small enterprises. A lot of companies which offer services to public sectors and the government use these microcontrollers extensively. So the employment opportunities are there in the core industry. If you're adding your skills on microcontrollers, there are a lot of applications that are there in the core industry. If you're looking at employment opportunities, R&D, and probably, of course, you can also build your own products. Entrepreneurship, you can build products based on this, so it can provide a self-employment opportunity. So there are a lot of opportunities in employment do exist in the quality control area, in development of embedded systems, being a firmware engineer, in terms of stack development, protocol stack, TCP/IP stack development. These are all embedded system-based applications which need knowledge on microcontrollers. So in the fields of instrumentation, in the fields of design of PLCs, drives, SCADA related applications. These are some of the statistics which I don't know whether students are interested or not, but this is a huge requirement in the R&D that's coming up. And there's the figures that are especially in the field of IoT and IoE. You're going to see huge investment that are coming in from throughout the world. So a lot of commercial opportunities. So a lot of employment opportunities are there if you are acquainting yourself with microcontrollers and the associated technologies. Of course, the requirements to understand this or move ahead should be able to demystify things, able to synthesize and analyze with basic common sense. And for any embedded system, because the embedded system is connecting to the real nature, so observation of the nature, because you are either controlling a temperature or measuring a temperature, so or any other things like material of could be strength of a material, it could be strain measurement. So basic high school level basics of science and life sciences and other things will be required to build systems of microcontrollers. In fact, we have used the word economy and other things also, because you have to build systems which are cost efficient, which are energy efficient, and it should have the required ergonomics or feel for the end user so that they are useful for the users. So broadly, that's it. But if there are any questions, I can go through those things, or if there are any specific queries of the basics, if a few minutes if I have to spend on the basics of the microcontroller, I can also do that based on the time availability today. Mr. Ahmed, can you intervene in this?
So Usha Mittal College, is there any questions from your side? You can raise your hand, or you may type in the chat box. Anything about the topic or about your final year projects?
How microcontrollers are used in transportation?
Is there a question from your side, madam?
One of the student wants to know is how microcontroller would be used in transportation.
Sorry. So the question.
How microcontroller would be used in transportation.
Okay.
How microcontroller is used in transportation, right? Okay. Let me explain. Transportation. Transportation. We're talking about transporting of goods, logistics. Someone, can you mute the audio there? Yeah. In case of transportation, so we use microcontrollers in transportation, especially one of the examples I can say is asset tracking. In the transportation, you're transporting goods from one location to another location. I'll give an example of one of the case which we have done for one of the dairy company. In this case, it was Amul. They had asked for a solution for the transportation of their ice creams and other products from one location to another location. So the problem the company had faced was the items have to be delivered to the end location with the right quality. So that means the air conditioner or the refrigeration system on the truck has to be on throughout the travel of about 1,200 to 2,000 kilometers, because from the factory to the dealer, the vehicle has to travel. So what generally a driver does to increase the speed of movement on the road, the refrigeration system of the truck sometimes is intentionally switched off so that it can move faster. And the items are delivered at the dealer, and in many cases it's found that the item, the ice cream or something is not of the good quality. So the customer in this particular case wanted to have a solution for this. So one of the solutions what can happen is with the microcontrollers, trying to get the data, whether what time the refrigeration switched on, what time is it switched off, what is the speed of the vehicle, and what all places it is stopped, and what's the temperature that's being maintained in the refrigeration system. If these parameters are not set, an alert is sent automatically to the factory or the concerned supervisor, so that they know that the transportation of the goods are happening as per intended requirements or not. So we have proposed a solution with microcontrollers, several microcontrollers, along with the GPS to take the data of the location. So the microcontroller with the serial port takes the data from the GPS, gets the latitude and longitude information, gets the speed information, measures the temperature, measures at what time the refrigeration is on or off, And based on this, we can build systems with microcontrollers for transportation applications, transportation of goods. This is one application. We can have many such things like if you just say, if you just broadly say it's in the automotive industry. I think every car has a microcontroller. Most of the trucks today, the Volvo buses and all these high-tech buses are primarily based on embedded systems. Did I answer the question? Is it clear?
So there is one more question from Usha Mittal College.
Okay.
So it is there on the chat box. Can you elaborate on the IoT and how is it different from embedded system?
Okay, I'll do that. IoT stands for Internet of Things. All of us know Internet as Internet of Computers, because for several years we have been interconnecting the computers. So network of networks is Internet. I think all of us know that network of networks is Internet. So in this particular till date, we have been using Internet for communicating data across computers. It is not that a device was communicating with another device over the Internet. So Internet of Things enables devices to be connected to the Internet rather than just computers. They not be just computers or mobile phones that are connected to the Internet, but the devices, like for example, a refrigerator at home, or your water heater or a geyser at home is connected over the Internet, and it also knows that you are driving home from an office or wherever. So based on your driving home, it would like to keep the hot water ready for you. So in such an application, you can consider that application as an IoT application, where the devices are over the Internet communicating with each other to accomplish a particular task. So we have seen smart refrigerators which will order milk or water products automatically to the stores. So these are Internet of Things. So how an embedded system is different from an Internet of Things? Okay, embedded systems not necessarily may have cloud connectivity, Internet connectivity. A simple embedded systems may not have Internet connectivity. When you have an Internet connectivity and using Internet to communicate to over the cloud to another device or other computer, then we can classify that type of embedded systems as an Internet of Things. So at a primary level, did that answer the question?
So I hope that answers the question.
Students will come ahead and ask.
Yes.
So can you please tell us about microcontroller robot? You talked about asset tracking, right?
Asset tracking?
Yeah, you talked about asset tracking earlier as an application of microcontroller. So my question is, which microcontroller would be most viable for implementing fuzzy logic in a automotive robot system?
Right. Okay.
Would PIC microcontrollers be? What do you think of PIC microcontrollers?
PIC can be used. PIC can be used. All depends on how much is your code size and what your processing speed required. Can you mute the audio, please? Samarth, can you mute the audio there so that? Okay, yeah. So the question was what type of microcontrollers have to be used for asset tracking, and maybe there's a requirement of fuzzy logic to be implemented. There's no specific thing like this. Only this microcontroller can be used. It all depends on your core size and your processing speed requirements, and the drain that we expect on the battery, or if it's a battery operated device or a mobile device. Based on that, so you have these choices of what's the power requirement and what's the processing speed requirement and what is the cost requirement, of course, and the code size requirements. Based on this, you have to make a selection. It's any controller can be used. We can use Atmel series or microchip series, or we can use Silicon Laboratory chips. if you also have an analog interface or a analog to digital to analog interface in your application, you can go for Silicon Laboratory chips. There are Texas Instrument chips available, Philips NXP, ARM controllers available. It all depends on your cost, your power requirement, and your size requirements and and things like that. IO line, number of IO lines, the amount of firmware size you would intend to put. So no specific, there's no thumb rule as such, but based on all these parameters, you have to take a decision on your application. Did it answer the question?
Yeah, one more question.
Yes. Please.
Sir, how microcontrollers used in electronic control units in automobiles?
Sorry?
Microcontrollers used in electronic control units in automobiles. Then how are they used?
It's not very clear. I could not get it.
Microcontrollers used in ECUs. Microcontrollers used in electronic controllers, that electronic control units, that is ECUs in automobiles.
Yes. What is the question? You want to know how they are used, is it?
She wants to know about, yeah, how does the microcontroller is used in the ECU of automobile?
Okay, engine control interface, not automobile. Yeah, as I heard the question, I think what is the role of a microcontroller? How is the microcontroller used in the ECU of an automobile? Okay. Mr. Samad, shall we just play a small video clipping of the basics of microcontrollers, because I think the J&K college students wanted to know some of the basics. Shall I play a small clipping of basics of microcontrollers?
Yeah, sure, sir. So you may start
I think,
share screen.
I think they got out of sync. I think they got out of sync and probably they're not following. So I have a small clipping on the microcontroller basics. I'll just play that. Before I address this question, I'll just play that.
Share screen option.
Yeah, I'll share it.
So, sorry to interrupt. I think the audio is not fair enough.
Is it? Okay.
So when you start with the share screen, when you click on it, there is a window, pop-up window, which says share the screen with the audio also.
Yeah, I've already said that. I've clicked on that. Audio is not very clear, or it's not. Audio is not at all coming.
No, it's not at all coming.
Okay. Okay.
So I think it's a short 5-minute video.
Yes. It's a short 5-minute video. I'll do one thing. Okay. I'll try once again. Okay, let me try once again.
Or else we may take up the last question, which was coming from Usha Mittal. It's still the same.
Okay, okay.
So we may take the last question that was about ECU from Usha Mittal before we end up this session.
Right. Yes, the question was on what or how a microcontroller plays a role in the ECU of an automobile. Okay, as all of us know, the performance of an engine is primarily decided on what amount of fuel that gets into it and what time the fuel gets injected into it. So these two are some of a few parameters, and of course there are parameters like the temperature, the flow, and other aspects. So in an ECU, engine control unit, the microcontroller plays a role of fetching these parameters, processing them, checking with the preset values, and based on the condition, based on the inputs that are provided, like in which speed you are in or which gear you are in, or based on other parameters, the decision to either increase the fuel or decrease the fuel or control the other parameters is taking place. So broadly, it could switch on a few solenoids or switch off a few solenoids or control the flow based on these inputs. So any microcontroller, even in case of ECU or any other microcontroller embedded application, there are parameters which are digital in nature, which are coming to digital. We can say digital parameter. A digital parameter is either 1 or 0. It's a state of either it's open or closed. Or another type of input, it could be analog in nature. Analog nature could be maybe sensing an voltage or sensing a current or sensing a flow or sensing temperature or sensing humidity. So even in case of this particular application, you're sensing some analog parameters, you're sensing some digital parameters, setting some things to the external world, again, which could be analog in nature or digital in nature. Again, the setting, if it is digital, that means you're switching on something or switching off something, 1 or 0. Or if it's an analog output, so that means analog output is you're controlling a flow of something in an analog form. That is, you're either setting. So even that analog can further be put into discrete terms or certainty terms by using digital steps. That the analog parameter, which could, instead of saying it's 0 to 100, we can say, okay, it's between 0 to 10 is one slab, 10 to 20 is another slab, 20 to 30 is another slab. Those are 10 discrete steps. So more it's digital, it's more certain. So you can always design systems as per that. Even in case of an engine control unit, as in your particular question. So microcontroller obviously has such type of functionality. Of course, automobile electronics itself is a vast subject. Maybe we can, in a future day, if you want to get into the more details of how and in what way embedded systems can be used. I think there are a lot of information available over the internet. And if you get a chance to interact once again, we can share that information. Is it okay?
So I think we'll end up the question and answer session here. And if the students at all want to interact more with Prem sir, so they can directly mail us and we'll get in touch with Prem sir. Is that fine, sir?
Okay, that's fine.
Okay, sir. So thank you very much for joining in. We really appreciate sharing your time, your experience, and your knowledge on this subject.
Okay, thank you.
Thank you very much.
Hope the students also enjoyed it.
Yes, I hope the students enjoyed it, and we'll be getting the feedback from the colleges, which will be shared with you.
Okay, thank you.
Thank you very much.